Question 10. The mean exam score for 46 male high school students is 21.5 and the population standard deviation is 5.3. The mean exam score for 57 high school students is 20.3 and the population standard deviation is 4.8. The fact that they're giving us population standard deviations here is very important. This tells us we're going to be doing a Z test, not a T test. At alpha equals 0.01, that's the level of significance, can you reject the claim that male and female high school students have equal exam scores, right? Equals, so we're looking at mean 1 minus mean 2 equals 0 versus not equal 0, right? Or in other words, down here, for our null and alternative hypotheses, we're looking at that they're equal versus not equal. B is the answer. A looks similar, but A cannot be right because a not equal symbol can never go in the null hypothesis. Equal symbols can go in the null hypothesis and never in the alternative, right? So between these two, A and B, even though the hypotheses are the same, we have to pick the one which has them in the correct order. Right, the claim here is that they have equal exam scores. That's A. Now we need to find the critical values. So this is a Z test, right? We said it's a Z test, and we're testing whether the means are equal or unequal. This is a two-tailed test. So we can draw what this looks like. A little sketch. We're going to have a rejection region on the bottom and on the top. We're going to have an upper and a lower tail critical value. This is because we have equals versus not equals. That's a two-tailed test. So our critical values we're going to get from the calculator. And there's going to be two of them. We have the positive one and the negative one coming. So on the calculator, we go distribution. Now this is a Z test, not a T test, because we have population standard deviations. So we're going to go normal inverse. We make sure our standard deviation is 1 and our mean is 0 because it's a Z. And then for tail, we have a couple of choices here, right? One choice is because we have alpha equals 0.01, we can do central 0.99. Right? That would be thinking about, oh, there's 0.1 in the tails, therefore there must be 0.99 in the middle. The other thing we could do is we could do 0.01 divided by 2 and get 0.005 on the top and 0.005 on the bottom. So if we went here on a calculator and we put in right tail 0.005, that would get us the same critical value there. I'm going to do center 0.99, but like I said, we could do right tail or left tail 0.005 and it would still work the same. It'll be fine either way. So we're going to run this and we're going to get positive and negative 2.5758. Now they want two decimal places, so 2.58. So we get negative 2.58, comma 2.58. We're using a comma to separate answers. We're reading carefully. We're doing the correct number of decimal places. We're not going to make any silly mistakes on rounding. So what are the rejection regions? Well, we're going to reject if Z is greater than 2.58 or less than negative 2.58. That's based on our critical values here. Right? The other ones all have the wrong numbers. So this one has to be right. And now the next part is based on the actual test. So we're going to go on the calculator, exit out of there. We're going to go test Z to sample. Standard deviation 1 is going to be for males 5.3 and for females 4.8. The sample mean for males is 21.5 and there were 46 of those. And then the sample mean for females is 20.3 and there were 57. And then we just run it. We get our test statistic is 1.19. And this is not in the rejection region, right? If we were to draw this out, we have here our critical values of negative 2.58 and positive 2.58. And our test statistic was 1.19. So that's going to be like around here or something. Right, so that's not in the rejection region. It's not in the red shaded areas. So we're not going to reject the null hypothesis, right? We fail to reject the standardized statistic is not in the rejection region. At the 1% significance level, right? 0.01 is 1%. There is not enough evidence because we failed to reject. Not enough evidence to, are we going to support the claim? Were we trying to support or reject the claim? What was the claim? The claim was the null, that they have equal. So we were trying to reject it. We have not enough evidence to reject it. If the claim was the alternative, we're trying to support the alternative and reject the null, right? So when they say the claim, you have to know which one was the claim. Was the claim the null or the alternative? In this case, the claim was the null, they're equal. Right, so that's a spot where students will get tripped up pretty easily. But there's not enough evidence to reject the claim that they have exam scores that are equal to female exam scores. Right, that was the claim, that they're equal. And so this is it. This is question 10. It's our 2-sample Z test.